Hi, welcome from my side. Thank you for joining my talk. I'm Jonas, working for Eclipse. We are a company focused on designing and implementing tools, and we are also heavily involved into open source and especially the Eclipse modeling ecosystem, which leads me to the topic of my talk today. I would like to present you a Ecore editor running in the cloud and also talk a little bit about how we build that. Before we dive into the technical part and the demonstration, let me give you a very quick introduction on why we did that and what Ecore and EMF actually is for those of you who do not know Ecore or EMF. So EMF is a simple and pragmatic approach for modeling data. It is heavily or often used for domain-specific languages and data-centric tools. And the idea is there is a language called Ecore, pretty much like UML class diagrams, that you can use to define your models and then generate entity classes based on this model definition instead of manually writing them, which has a lot of advantages. I will not go into detail due to the length of my talk. Now, why do we care about EMF in the cloud? Isn't that a desktop technology? Now, no, it's actually not, because large parts of EMF are just headless APIs, and it's very mature. So, for example, there are APIs for model manipulation, for serialization, there's a code generator, and all this stuff doesn't really have a dependency on any desktop or UI technology. It's easy to reuse it in the cloud. Even more, it provides access to a very large ecosystem around EMF that has developed over 20 years now, containing solutions like, for example, EMF Compare for model versioning, EDAP for model evolution, the EMF validation framework, and many more. Now, if we can continue to use EMF for the headless part of our tools, we can just continue to use those solutions, which provides a lot of benefit. And last but not least, we have an out-of-the-box compatibility with our existing models and instance data. So the migration case is much easier if we support EMF and Ecore in the cloud. Now, there are two projects that we heavily use in our Ecore editor in the cloud. First one is Eclipse Theia. We integrate into that. In case you don't know what Theia is, which is unlikely after visiting this conference, but it is an open source platform for building web-based tools and IDEs. So you can consider it to be the kind of the web version for the Eclipse tool platform. And we integrate our Ecore editor into that. It would be easily possible to do the same thing in VS Code or another web platform, but this was just a natural choice for us. And the second project is emf.cloud. emf.cloud hosts the Ecore editor, and the general goal of the project is to enable the benefits of EMF in web-based tools. This has two streams. One is it provides a lot of adapters to migrate existing EMF-based applications. So, for example, it enables to use EMF API in web-based applications. However, there's a second stream. It also implements new components that are independent of EMF, but work well with EMF. For example, the diagram technology that I show you today, GLSP, works well with EMF, but also works without EMF in case you don't have an existing model or you just don't want to use EMF. So that means EMF Cloud is not necessarily bound to the desktop version of EMF. Long story short, the goals that we had in mind, obviously to enable equal modeling in Eclipse Theia or in the cloud. And our second goal was to reuse as much as possible. So this Ecore editor might be a good blueprint for you to look at if you have an own tool that you want to migrate or implement in the cloud, because it contains a lot of solutions how you can actually reuse existing tool components in this scenario. The feature set, if we look at the basic workflow of Ecore or EMF, you create a model first. We do that in a graphical editor, so pretty much like a UML class diagram. You define your entities, and then you generate code from that, and the output is Java classes. Now, more fine-grained use cases are, first we want to create a model. We want to graphically modify and extend it. We want to generate code. We support a property view for enhanced properties of the entities, and we support the validation to find errors and mistakes in our model before generating the code. Now, before we dive into the demo, let's look at a very simplified architecture which helps you to understand what we actually did and how we were able to reuse a lot of features that were already there. Now, the basic architecture of Theia is a split between a front-end and a back-end component. The front-end component is running in the browser, JavaScript or TypeScript, and basically implements the UI, and the backend typically hosts all the business logic of an IDE or tool and is based on Node.js. This typically interacts with the file system then. Now, the first thing that we did is we extended the front end with a client extension, implementing the UI parts and, for example, commands to trigger actions. And on the backend, we added a pretty slim component that we call the Ecore server, for our backend features. Now, what we didn't want to do is implement all the business logic that we have in EMF or in the Ecore tooling in TypeScript, because it's already there in Java. Now, luckily, it is very simple and foreseen to integrate other languages on the Theia backend. And what we essentially did is we repackaged a lot of the features that are there in EMF. We did not re-implement them, but made them available in the component. I call it EMF model server now in a simplified way. There are a couple of subcomponents, which is not like super important by now. As you can see, the server part, I mentioned a technology called GLSP here, which is pretty central because that's the technology providing the diagram that I will show in a sec. Let me quickly introduce that a little bit more in detail. The technology we use there is the Eclipse graphical server language platform. If you're familiar with the language server protocol, that's pretty much the same concept, but for diagram editors. The basic idea is we want to keep the client as generic as possible, not language specific. So it consists of a generic client that is just there for rendering the information. And it renders based on a graphical representation. This graphical representation is synchronized between the client and the server. Now the server can manipulate this representation and therefore update the client and vice versa. So for example, if the client adds a new node, the server will be notified and can react accordingly. Those two components are encapsulated via a protocol. It's a GLSP protocol, which is based on Eclipse Proti. That's the underlying diagram technology, and GLSP adds commands for specific for diagram editors. And now on the server, because it's encapsulated via a protocol, we can choose any language to implement it as we want. And in our case, we obviously use Java, providing us access to the EMF API, because the responsibility of the server is then also to adapt the underlying data, in our case, an Ecore model or an Ecore file. And this is very convenient because we are in Java and we have access to EMF, we have access to the command stack, the serialization and everything. So that makes it very easy to provide this diagram editor in the web, because the business logic doesn't need to worry about the rendering part. All right, long story short, let's dive into the demonstration. Let me go full screen and switch over. All right, what we see here is an empty Theia instance with an empty workspace. This has our Ecore tooling integrated. So let me create a new project to host my model, and following the convention, a model folder. Now, the first simple feature that we support is creating new Ecore files. I could manually do that, but an Ecore file has a certain header, like an XMI header, which I just couldn't create manually. So this is supported. Many features that I will present you today are integrated in this command bar that I can open here in Theia. You probably know this from VS Code or Theia. Now, this is a great usability concept, replacing those huge context menus, because I can just type in what I want to do, for example, creating an Ecore file, and then it leads me to the command. Now, this starts a mini wizard in which I can enter the parameters for the creation, for example, the file name, the prefix and URI. And now if I press enter, this will actually call the service on the backend and the emf API to create the ecore file. And now if I close that and just the diagram editor and just look at the underlying text file, you can see this is now created by plain EMF. So we didn't have to re-implement this. For the file creation, this is obviously a small thing, but you will see on the other features that this really helps that we don't have to re-implement these kinds of features. All right, let's open the graphical representation and show you the GLSP diagram editor. So as you can see, we have a palette. We can start to create classes, for example, a class named task, a second class, maybe let's name this user, a reference, so pretty much like the feature set that you're used to from the desktop. I can change the layout here. I can change the multiplicity to 0 star. I can add attributes. This is a good example where we see the integration of the EMF backend. So if I select the type here, as to just E, I see all the available types, and this is actually again derived from the EMF API that is running on the server. And I can select something. Another example where this plays a role is, for example, if I define a new data type, let's say an enum, and let's define this to be open or closed. Now I defined a new data type, and if I now add another attribute to my task, I can actually directly reference this data type. So this is the semantics that is provided by EMF in the background. So we don't have to re-implement that. As you can see, if I save the file, it creates a second file that contains the graphical notation, pretty much like you used to from the desktop tooling. And the ecore file contains the underlying domain model. If I open that again, I see that this is the default EMF serialization. So we have the user here, the state, and so on. So this could be processed by any EMF-based framework. What else to show? So for example, if I accidentally created a class, I have undo support, again, based on the EMF command stack. I have support for validation. So let me open the problems view here. And now create an error in my model. For example, let's change the multiplicity to 1, 0, which doesn't make much sense. I can validate my model here by clicking here. This will trigger the EMF validation on the server asynchronously and send back the result. And as you can see, I even did 2 errors because the upper bound must be greater than 0 and the lower bound must be lower than the upper bound. So you can see here, those are the original error messages produced by the EMF framework. So we didn't re-implement any constraints. We basically used an adapter that is provided by emf.cloud that can transform those error messages into GLSP markers. And you can see they're integrated in the problems view and also here on the left side in the file menu. So let's revalidate, and now everything is good. All right, let's show you the code generation. In case you're familiar with EMF, you know that I need a gen model to generate code. So let me quickly generate one or create one. We have an action for that too. I can either use default values or specify all the parameters. And for time reasons, let me just use the default values. So that will just take the package definition and names from the eco model and create a default gen model. As you can see, we don't provide an editor for the gen model yet. That might be a future feature that we implement. But for now, you would need to change that in XML. And now, once I have a gen model, I can call another action called generate code that now calls the EMF code generator in the background. And we see it created a new folder here. And if I browse here, I see the result of the default EMF code generator that has been adapted. By the way, this shows another nice advantage of being integrated in a platform like Theia, because we automatically have syntax highlighting for Java code, auto-completion, and all the features that you would expect from an IDE. Another thing that I could do, for example, if I open the STM view, I could just initialize a Git repository, and let's say I just stage all those changes and commit them um, to a repository and share them with other people. So now my changes would be committed, and now I could continue and share my work with others. And the last feature I would like to show you today here in this demonstration is the property view. So let me open that. What you can see here is a generic property view integrated in Theia that we implemented. So it shows the properties of files, for example, but you can plug in custom renders, and that's what we did here for the diagram editor. So if I click here on this entity, I see down here the properties of this class. I can change that, and you see it's live updated. That's actually enabled by the model server component again, which provides change notification. And this is also working, for example, if I make this an abstract class, we see that the rendering changes here and obviously back. All right, there would be a lot more to show. For example, this diagram technology like GLSP and Sprotty supports zooming. It supports big models well, with a lot of other elements in the palette, as we can see. But for time reasons, let me switch back to my slides, because there's one more topic I would like to talk about. And let me make myself visible. Hi, it's me again. And I would like to talk about cloud hosting. So far, the demonstration that I've shown you, as you might have noticed from the address bar, was running on my machine. But this cloud-based tooling gets really interesting if you deploy it in a remote location and provide access from everywhere just using a browser. Now, there are several ways to do that and to deploy that. One possibility that I would like to show you today is Eclipse Che, another Eclipse project, and that is a workspace server for cloud-based tools. What is a workspace server? If we imagine that our tool, especially the server part, um, deployed in a cloud-based scenario, we need to host that somewhere. So we need some runtime where we can execute the Theia backend plus our Java EMF model server and the file system, because those components need to they belong together and we need to deploy them somewhere. And if we imagine that several people are using this tool, we need some sort of solution or some sort of server that is capable of managing those runtimes, starting them, stopping them, maybe even sharing them with other people. And this is exactly what a workspace server does, and Eclipse Che is an open source solution for that. Now, Che integrates Eclipse Theia already as a default IDE, but even better, it allows you to integrate custom editors. And what we did is we created such a custom editor based on our Theia version, which is extended by the Ecore tools, and integrated that in Che, which enables us to run our Ecore tooling based on Che and therefore deploy it to the cloud. I will demo that, but I will show you a video because I didn't want to risk starting a full Kubernetes cluster at the same time while streaming. So bear with me. This is a video. So here we see the Che dashboard where you can actually create workspaces as a developer. Now the interesting part is once you created a workspace, you can select editors. From a list of editors, we see different choices like Eclipse Theia is the default, and we added our Ecore editor to it. So in different version, and now you can actually select the Ecore editor, meaning the Theia version with the Ecore tooling instead of the standard editor with your workspace. Then you can launch the workspace. Let me move a little bit forward. What I forgot is you can also add a Git repository on startup, so that the new workspace would automatically check out a certain project that you're working on. And now Che is actually launching this workspace. You can see that down here, the progress. Let me jump a few seconds to not lose too much time here. And now you will see that Theia is starting up. as you saw before, and it will present you the project that it has checked out, like our Ecore project that I committed before, and the Ecore tooling integrated into the Theia instance. So let us open the workspace. Here we see this demo project, and we open the Ecore file just like this. As we can see, we are using the dark theme here. That shows that, for example, the diagram technology works well with theming. So if in case you apply any custom theme, that usually adapts quite well. And now we can create another class of the Ecore tooling here running in Che and now deployed in a cloud context. Now, another nice thing about this cloud deployment is that you can very easily share now your workspace definitions with other people. So for example, in Che, if we look at the workspace configuration again, you can actually just get a file. We see that here. That defines exactly which editor you run and which repositories to check out. And if you provide that to a colleague, he or she can actually get on board of your project essentially with one click. So you just paste this file, have to wait a little bit until the workspace comes up, but then you can just onboard and, for example, continue to model or use the Ecore tooling. All right, with that, I'm coming to the end of my talk. So let me provide you a quick outlook and the current state. So currently this is all in alpha version. You can download it, you can try it. It's released on the EPL, and it is available in the emf.cloud project. We are continuing to develop new features. What we currently have in the lab is an integration of EMF compare. You see a screenshot down here. This is actually two versions of a diagram being compared, and we see the colors show that, for example, on the left side there are two nodes or two classes added. On the right side, the red ones have been deleted. And again, this is achieved by integrating the existing EMF compare technology on the server and just visualizing it in the web frontend. What we are looking for is contributions. If you want to join the work, feel free to do so. Get in contact with us. We would like to learn if you're interested in using such an editor. And obviously, if you would like to sponsor some of this work, we are happy to discuss any of your adoption cases with you. So let me come to a conclusion. I think I could show that reusing existing components on the server allows to reduce the effort a lot and preserve your existing investments. Examples like the validation and the code generation or the undo redo stack and all this, we don't have to re-implement that. You can also preserve custom extensions and DSL specifications that you might done with EMF plus your instance data. So it's a pretty attractive migration path. Projects that I've shown today are the EMF Cloud project hosting the Ecore editor and a lot of the adapters that I've used, GLSP for the diagramming part, and JSON forms for the property. Now, before I open it up for question, I know this was a lot of stuff in a short session, but I hope you enjoyed it. In case you did, please consider to evaluate this session because your feedback will help future program committees to select good content. And with that, I would like to open it up for questions. And I got quite a lot of questions, so let's move into those. Okay, first question is, desktop Ecore editor allows to store diagram layout in a file. Does the web editor also allow to store layout? Yes, we have seen that. That's this E notation file. That's not the same syntax as the current zeros-based one, but it allows to store the layout. Second question, I've learned that LSP can be extended for custom use cases. Why was GLSP created as a separate protocol? Yes, you can extend to LSP. Like for example, Sprotty does that, but this extension is rather small, allowing to send Sprotty or diagram specific commands. For GLSP, we didn't do that because we want to be able to run GLSP without a textual language. So the extension done for LSP is really rather small, and that's not like justifying dragging in the requirement to always have LSP underneath. Does it support eco models referencing other eco models? That's a very good question. Currently not yet. As I mentioned, this is a first alpha version. That's obviously a feature that you need in a lot of projects. So you might do that, but we're also very happy for contributions there. Is it possible to synchronize a Theia project with a local Eclipse project? Yes, for sure. So the simplest way is to just use Git, for example, for that. But also, if you run Theia locally, for example, you can just write to the same directory. So that's definitely possible. Is it planned to add gen model content in the property view, like the series-based equal editor? Again, this would be very nice. Was not on our priority list so far, but would be a nice feature. Again, we are happy for all contributions. Does it allow to have several diagrams on top of one eCore? In general, so technically, yes. So GLSP supports that and all the underlying technology, but it is not yet implemented essentially. So, but it would make sense, especially for huge diagrams. In turn, if you use eCore, one best practice is actually to keep the single eCore files to the size where you can actually still display them on a diagram, but of course it depends on the use case. More questions. Is there a specific reason why you created a new editor for Che rather than a Che plugin for Che Theia? Yes, there is. So this is actually based on an extension of Theia. So we use some capabilities of the more powerful extension mechanism of Theia. It would be probably also possible in the meantime to provide a similar feature set using VS Code extension, and then you could actually bundle that into a cheap Theia plugin too. In the Che example, is the eCore file stored in a Git repository? Does the model server need to persist files to a Git repository for versioning? So no, model server and Git repository are really two completely separate things. So the Git repository is really used as in any other context to synchronize your data between you and other project participants, while the model server is really only used to synchronize the different UI parts you have and enable things like undo redo and the model access technically. So the model server is not to collaborate with others. It's really something that is really local to your IDE. So you could also more like the local model server, it is running remotely, but it is not something like Git or CDO or EMF store. It's really more a technical feature that you need in this remote scenario. Is there a mechanism to load files from the local file system with notifications on change the files? I'm not sure whether I understand that question. So if you're in a remote, you can upload files, but then you would not get any notifications. I'm not sure. Sorry, maybe I don't get that question correctly. In the Che example, the eCore, that's a similar question, is stored in a Git repository. Does the model server need to? I think I answered that. And one last question. EMF is not thread safe. Do you plan to enable collaborative editing, and how do you expect to work on the same model by multiple persons simultaneously? Very good question. So I think that's kind of an upcoming research topic. You could, like, there are existing solutions to modify EMF models synchronously or simultaneously. I think the more interesting question is like how do people work together? Is like modifying a model is not like modifying a text document, because you have to stay semantically correct. And if you want to go beyond just sharing the same screen, I think you need some additional mechanisms. So at the moment, like the regular mechanism to share between two people is Git, but obviously those online tools would enable great use cases for collaborative modeling or simultaneously modeling. But I think we need to think about the way to do that to not end up with models that do not compile. Thank you very much for attending the session.